Okay, guys, now I'm going to show you how you solve the transportation problem or the logistic network design problem that we stopped at last time using Excel and Excel Solver. So we have to create a model on Excel. The way to create the model is to go through the three steps that I introduced in the previous lecture. The three steps are first, identify the decision variables. Second, introduce the constraints. Third, formulate the objective function, and finally solve. So the first step is to introduce the decision variables. If you recall, the decisions are about determining the quantities that should be shipped from every plant to every warehouse, and then from every warehouse to every customer. The constraints incorporate maximum capacity of the plants, the customer demand that must be met, and there is a third kind of constraint that I will introduce while I am building this model. So the first step is to introduce the decision variables. The decision variables are about the quantity to ship from to. Here I am going to identify, plant 1, plant 2, to warehouse 1, and to warehouse 2. Obviously, these are quantitative values, so I'm going to start with 0. I will highlight them with red so that I recognize them later as the decision variables to be dealt with. Another kind of decision variables are about the quantity, okay, to customers from client, warehouse 1, from to customers from warehouses, so from warehouse 1 and warehouse 2 to customer 1, customer 2, and customer 3. Again, these are zeros, and they are decision variables as well. Okay, once we're done with defining the decision variables on Excel sheet, we have to start introducing the constraints. The first type of constraints are the capacity constraints. That means that every plant has a maximum capacity. Which means what? It means that the total quantities shipped from every plant to all warehouses, both warehouses, should not exceed the maximum capacity. Let's compute the shipped quantity from every plant. It's basically the sum of those two quantities when they are evaluated. And with copy paste, you can do the same thing for plant number 2. The max capacity are, if you recall them, 200,000 for plant 1, 60,000 for plant 2. So these are the two maximum capacity constraints. The second type of constraints are the customer demand that must be met, which means what? That the shipped quantity from every warehouse, okay, from both warehouse to the first client, in this case the sum of these two, this sum represents the total quantity shipped from both warehouse 1 and warehouse 2. So that must meet the demand, okay, required demand. For customer 1, we know that there's got to be 50,000 units to ship to. We do the same thing for the other two clients and introduce the required demand for both of them. Um, okay, 150,000 for customer 2 and 50,000 for customer 3. So later on when we build the solver model, we have to specify that those shipped quantity must be equal to the required demand. The third type of constraints is the following. Every warehouse should not keep any left over, which means that all quantities that go into it must leave it. So total shipped in must be equal to total shipped out. So let's introduce the total in the warehouse. Okay, how do I compute it? So whatever goes into the warehouse from plant 1 and plant 2, add them up, we get the total shipped into it. So it's basically the sum of these two quantities. Same thing goes with the second one. Now the total out, okay, is basically everything that goes out of the warehouse to the three clients. So it's the sum of these three plus the sum, oh sorry, and this same thing goes with the second warehouse. So in solver we're going to specify that these two ranges must be equal 1 by 1 respectively. So we're done with the decision variables and the constraints. Going into step number 3. Step number 3 means that we have to build and formulate the objective function, which is in this case the total transportation cost function that must be minimized. In order to build the total transportation cost function, we have to introduce the unit transportation cost that happens through every shipment. So the unit transportation cost, okay, from plant 1 and plant 2 to warehouse 1 and warehouse 2 are already defined. They are given by the problem as 0, 5, 4, and 2. Same thing will go with the shipment from warehouses to customers. So basically, from the warehouses to the customers, they are 3, 2, 5, 1, 4, 2, and we have to double check. Now we have to build the total cost function. Okay, to build it means that we have to multiply the quantities to be found of the shipments from plants to warehouses by the corresponding costs, and add to it also the the total shipment cost that corresponds to the quantities to be shipped from the warehouses to the clients times the corresponding unit cost. For this purpose, we're going to use a function on Excel, which is called sum product. This sum product means that you have to multiply two ranges, such as this one, and the corresponding quantities like that one. These two ranges must be identical. It means that it's going to multiply every cell in every range to the corresponding cell in the other range and add them up at the end. So we have the total transportation cost from plants to warehouses. We have to add to it the sum product of the total cost that corresponds to the transportation from warehouses to clients, put a comma, and to the corresponding ones. I think there is a problem here. Sum product, okay. We have a problem here. Yeah, here you go. It's there. That's because of the fast typing. Now it's fine. This is my objective function. I'm gonna highlight it with green so that I can recognize it when I build the solver. Now to use solver, it's an add-in for Excel. You find it under data menu. It's got to be somewhere here. If it happens that you don't find it, then what you've got to do is to go to File, okay, Options, go to Add-ins, Make sure you're using and managing Excel add ends. Click go and make sure that you pick solver add in. If you're done with that, it's gonna show okay, this is solver. It's a window in which you're gonna incorporate the requirements for the problem to be solved. The objective is my objective function. It is basically my my total transportation cost. Then I have to introduce the variable cells. Okay, this is one set of variables. Put a comma, introduce the other set of variables. Okay, now add the constraints. Okay, the first kind of constraint is that the total quantities shipped should be no more than the capacities, corresponding maximum capacities. Another one is that the total quantities shipped to customers should meet the demand, equal to the required demand. And don't forget to introduce that total in to warehouses must be equal to total out. Total in must equal to total out. Finally, all these quantities should be integers because we're dealing with units. So basically, this one should be integers, and this range should be all integers. We're done. Make sure to use simplex and click solve. So we found the solution. Click OK. And the solution is shown with these quantities to be shipped. So 140,000 units from plant 1 to warehouse 1. Those 140,000 units are going to be divided into 50,000 units to customer 1, 90,000 units to customer 2, and then the all of the capacity in plant 2 are going to be shipped to warehouse 2 and will be divided to customer 2 10,000 and customer 3 50,000. The total cost, which is the minimum in this case, is 740,000. This will be it. See you next time.